Hello and welcome to Engineering Lab 608. My name is Mr. McGovern and I teach Intro to Engineering Design and Aerospace Engineering, both honors classes. Let me tell you a little bit about myself, give you a tour of the room, some of the things that we do in here, some of the equipment that we have in here, and then I'll give you an idea of some of the projects that we do in this course. So I am a 2005 Courtsville High School graduate, former student of Mr. Kearns and several other teachers on campus. I'm a prior aviation teacher from Palmdale School District. I'm also prior service. I did 3 years in the Army as a diesel mechanic. And then my contact info, should you need to get a hold of me, should you have any questions, is my email is amcgovern, AMCGOVERN @avhsd.org. And the number here at the school is 661-718-3100. And the extension for my room is 609. I teach, like I said, intro to engineering design and aerospace engineering. Those are two of the 4 engineering courses that we offer here at Courtsville High School. The other two being Principles of Engineering, taught by Mr. Bell, and Digital Electronics, which is taught by Mr. Kearns. Mr. Kearns also teaches along with me Intro to Engineering, but I am the only aerospace engineering teacher on campus. All of these courses are part of the Industrial Technology Department, and these classes are designed to be hands-on, roughly 80% hands-on, 20% lecture. So we want the students to work with their hands. And sorry for the bad camera here, but we do all kinds of different projects, and we have different pieces of equipment, scroll saw, some of which these things are new to us. We have a new drill press, we have a new bandsaw. We've got lots of hand tools in the toolbox over there, as well as in some of the other cabinets. So we go through and get the kids hands on and give them basic knowledge of some basic hand tools, how to use them, proper usage. We do a safety test, being that this is a lab. Students have to pass the safety test with an 80% score or better. If they don't, they have to retake the test until they receive a passing score of 80% or better. Until that point, students are not able to use any of the lab equipment or be in the lab. For the Intro to Engineering Design course, we have several different projects, one of which being a puzzle cube. I'll walk you over here and show you an example of that. So we have pre-cut cubes that the students will assemble themselves. So they design their own. So each piece needs to be laid out. We draw it out on sheet paper, on graph paper, isometric graph paper, and then the students come up with their own design, try to make it as complicated as they can, and then we do the hands-on portion where they glue all the pieces together, make sure that everything fits properly, and then take it home and challenge you as parents to try to solve it. Another project we do, another part of that is using 3D modeling software called Inventor. I'll bring that up and show you an example of that. Inventor is an industry program. Lots of engineers use that out in the field. So here we've got a digital example in the program of the different pieces. This just happens to be one of mine that I use as an example for the students. So they build each of the pieces in the program. They have to get used to understanding how to create it in here. They need to know about dimensions, they need to know lines, they need to know construction lines, object lines, so on and so forth. The end result is putting the puzzle cube together just as they would physically with the real wood pieces. Another project we do is we do quite a bit on Inventor, trying to get them a real solid understanding of how to use the program. Another is building kind of a high performance type wheel. So I take them through that, start with a real basic sketch and use some of the different features in the program to create that. And then they go through and they'll color it themselves, make it look as realistic as possible. We even add a little bit of tread on the end of it, make the tires look realistic as well. Next thing we do is a train project. This is kind of taking all those skills that they've developed in Inventor and putting them to work. So they will build, this is just the train body and the track, a couple of the parts. I wanted to show you that. They'll end up putting the entire assembly on there, but the train itself looks like this. And they'll build every one of these pieces individually. They've got to read the schematics. They have to be able to interpret the dimensions and which part of the train they belong to in order to effectively build this piece. This takes quite a bit of time. Some students get the hang of it real quick and they're able to blow through it. Other students, they have to take a little more time. Sometimes come in, get some extra help, stay after school, come in during lunch, stuff like that. Some of the aerospace engineering projects. The first thing that we do is history of aviation. The students will choose a topic from a list of 100 plus that I give them, and they'll do a video or a presentation based on that topic, and then they'll have to create a model based on whichever topic they chose. We have a few examples of these. All different planes. Lots of students tend to choose planes or blimps or dirigibles, flight simulator, satellites, and then it breaks down even further. Some of the topics go into specific aircraft parts, such as an altimeter or an artificial horizon or something like that. So they'll take those, the information that they gather from their research, and they'll build a model. The next project that we do is Flyboy. These are Flyboy kit planes, and they start out as just sheets of balsa wood that are pre-cut, and they have to pop all the pieces out. They have to read the schematics, be able to determine where each piece goes. Some of this stuff is cut to fit, so they have to be able to measure properly, measure twice, cut once, and assemble these planes. Some of them do not come out quite as they had hoped, and then at the end of it, such as today, we took them out to the field out by the football stadium, and we tested their flight. Some fly, some don't. Another project after that, we do hot air balloons. I don't have very good examples of those because they tend to burn up a lot, but the students will take various trash bags. I give them just a bunch of different materials, and they can do with it what they choose. Some students will take regular wire, heavy gauge wire, thin gauge wire. They'll take pipe cleaners, and they will burn off all the little hairs off of it to create their own wire. Aluminum mesh, aluminum foil, tape, pretty much anything that they can get their hands on, they can use, more or less. And then we use, with my supervision, we have cotton balls that we soak with kerosene, and that is our fuel. Tend to do this in the winter time, right about now. This is the next project that we're going to jump into when the air is still cool in the mornings, and we can go ahead and give them a better shot at getting some of those off the ground. It's a real real satisfying thing to see when the students are able to take just a bunch of raw materials and create something that can fly. Another thing that we do here, look at my list, the next one is the balsa gliders. Okay, so another aircraft build, balsa wood and some clay. But they've got to design these in a program on the computer, and there again they're taking raw materials, they're cutting it to length based on their design. They have to sand the leading and trailing edges of the wings of the horizontal stabilizer, make it more aerodynamic. They have to balance it front to back, side to side. If need be, they create control surfaces so they're able to get the plane to fly how they need it to fly. Some do just straight wings. Other students will do swept wings. I like to see this. It's a little bit more of a challenge for the students, but it's good to see when they take on that challenge. We also do, I'm going to try to get into some drones. We have some new drones here, some DJI drones. Try to give the students some background knowledge on drone usage. They're becoming real big, and they could be problematic if they're not used properly and if you don't know the regulations associated with drones. I did have a student that got himself into a little bit of trouble when he flew it out of its specified range. The last thing that we do at the end of the year, I like to save this for the end of the year because it's a really fun project, and the students get a kick out of lighting things off. So other than the hot air balloons, we do rockets. So they'll build these from raw materials as well. Cardboard tubes, plastic nose cones, balsa wood fins, solid fuel rocket engines, plastic parachutes. Those are real fun. And the kids, we save that for right before the end of the year, and they get a kick out of being able to do that. They will have the opportunity to design their own nose cone. So this is one that a student, he wanted to put a little Lego guy on the top of there and have him flying. So they designed in Inventor, so using that prior knowledge, designed a nose cone in Inventor and then 3D printed it. We have 4 new raised 3D printers. I've got a few things going right now, building some stuff for Mr. Hall, but very, very good printers. I did print a rocket that we're going to try to shoot off at the end of this school year. So this rocket here was 3D printed in pieces, 2 different bases with the body, a sleeve where the engine will go, and we're going to try to shoot that off. So the students will have an opportunity to take their knowledge that they've learned in Inventor, using the 3D software, designing something of their own. They'll 3D print it. They'll be able to put it on the rocket and watch it fly. And speaking of flying, we also have a flight simulator. Looking to get another one, but this is a STEM pilot unit, and it has some pre-programmed lessons in there about taxiing an aircraft, about landing an aircraft, navigating an aircraft. In Aerospace, we also go through some of the different instruments that are in an aircraft. I mentioned before with the History of Aviation project, we look at altimeters, we look at artificial horizon, we look at vertical speed indicators, stuff like that. So they'll be able to take some of that knowledge and apply it on the simulator to fly a plane. Again, if you have any questions, I will, in addition to telling you what my contact info is, I'll show it here on the video so that you have that. Before I do that, I'd like to show you a new development here. So this is a Zenith Air CH-750 cruiser plane. This is a true to life, real airplane, real engine. As you can see some of the dimensions here, it's 23.5 feet long, 9 feet tall. The wingspan, I believe, is about 30 feet, right up there, 29 and 9 inches. This is a real aircraft. This is going to be an opportunity for those students that take the aerospace class. If they do real well, they're in the top of the class in aerospace. This is an option for them to be able to put hands on a real airplane and build it. This is coming as a kit. So the students, just like they're doing with many of these other projects, they're taking all of the materials, they're reading schematics, they're being able to interpret the directions and build something with their hands. By the end of it, they'll have a functioning airplane. Whether or not we're going to be able to fly that remains to be seen. That would have to be checked off by the FAA, but that is a new development here coming in the 2022-23 school year. Most likely going to be a before school 0 period option, possibly 7th period, but I think we're leaning. Apologies.
Emily Laval, your ride is ready for you.
That's what happens when you're doing the video in your classroom after school. Sometimes the loudspeaker comes on. So my contact info here, right before we go, is, again, my name is Anthony McGovern. I am in room 608. My email, amcgovern@avhsd.org. Phone number 718-3100, extension 609. If you have any questions, feel free to email me, give me a call, and I'd be happy to answer those.